How does the transfer of sodium ions within the electrolyte contribute to the battery's operation, and why is this process crucial for the movement of energy in the battery system? What is the role of electron transfer outside the battery, and how does it work in conjunction with the movement of sodium ions to complete the overall reaction in the battery? In what ways does the behavior of sodium-ion batteries, including their ability to charge and discharge, make them suitable for use as secondary batteries? How do sodium-ion batteries function as secondary batteries, and what advantages does this provide for applications in various fields? Can Davis Zerns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How are sodium-ion batteries used in areas such as large-scale energy storage and low-speed electric vehicles, and what makes them ideal for these purposes? How can the research and modification methods used for sodium-ion batteries benefit from the technology of lithium-ion batteries? And what lessons can be learned from the development of lithium-ion technology to improve sodium-ion battery performance? How does understanding the comparison between sodium-ion and lithium-ion batteries contribute to advancing sodium-ion technology for future applications? How are the working modes of sodium-ion batteries and lithium-ion batteries similar? And what makes them differ from one another? What are the key differences in the properties of sodium and lithium that affect the performance of these two types of batteries? How does the position of sodium in the periodic table, being in the third cycle of the first main group, influence its properties compared to lithium, and how does its relative atomic mass of 23 grams per mole contribute to these differences? What are the characteristics of sodium's electron clouds, including their spherical and dumbbell shapes, and how do the 3s orbitals of the outermost electrons impact its behavior in a battery? How does the larger relative atomic mass and ion radius of sodium compare to lithium, and how do these differences influence the electrochemical properties of the two ions? What is the significance of the electrochemical equivalent of sodium being almost 3 times that of lithium, and how does this affect the performance of sodium-ion batteries? How does the lower desalvation energy of sodium ions and its stronger diffusion ability contribute to the unique advantages of sodium-ion batteries compared to lithium-ion batteries? What are the main advantages of using sodium in batteries, such as its wide availability on Earth, ease of mining, and high quality compared to lithium? How does the higher redox potential of sodium ions, about 300 MV higher than lithium ions, affect the materials that can be used in sodium-ion batteries, such as electrolytes, electrolyte salts, and aluminum collectors?